Welcome. In this screencast, we will try to explain to Calculus 2 students what we mean by sequences because we hit that in high school a little bit, but we want to expand our understanding as we approach Calculus 2. So just to be clear, a sequence is an ordered list of numbers. This is different than sets. Sets are unordered. Sequences are ordered. And so some examples, let's do some examples. Sometimes we abbreviate sequences as A sub n or B sub n or C sub n. N is the index. It lets you know what the first number, second number, third numbers in the list are, and so on. And we put the set braces around the outside to indicate that it is a sequence. So maybe the sequence A sub n is the sequence n minus 1 over n. This is the list. Well, let's see. When n is 1, this is 0. When n is 2, this is a half. When n is 3, this is 2/3. And when n is 4, this is 3/4, and so on. Maybe the sequence b sub n is the sequence negative 1 to the n plus 1 times n minus 1. What list is this? Well, when n is 1, this is the number 0. Sorry, this is the number 0. And when n is 2, this is the number negative 1. And when n is 3, this is the number 2. And then negative 3, and so on. Let's see. The sequence C sub n. Oh, let's not tell you what it is right away. Let's just pull out a sequence from our high school days, 5, 7, 9, 11, and so on. That thing is what we would have called an arithmetic sequence. And arithmetic sequences, they can be explained. So this is 5 plus 2 times n minus 1. Each little jump is a jump of 2. There are n minus 1 jumps past the first number. And then this sequence d sub n, we won't tell you what it is right away, but we will give you a list 4, 6, 9, maybe 27 halves, and so on. Well, this is not an arithmetic sequence because that's plus 2 plus 3, but this is a geometric sequence where the first term is 4, and then we multiply by 3 halves n minus 1 times. This is a geometric sequence. Sometimes sequences are generated by recurrence relations. So sometimes you have the first term of a sequence and a way to generate other terms in terms of what came before for n greater than or equal to 2. So if we want the second term in the sequence, we take the first term and multiply by negative 3. If we want the 10th term, we take the 9th term and multiply by negative 3. So this would be the sequence 2. 2 times negative 3 is negative 6. Negative 6 times negative 3 is 18. 18 times negative 3 is negative 54, and so on. You may find it interesting to try one on your own. Let's suppose that a sub 1 is negative 4 and a sub n is a sub n minus 1 plus 3. Let's write out the first few terms of that sequence. Hit the pause button, see if you can write out the first few terms. Well, there they are. Negative 4 plus a 3 plus a 3 plus a 3. This is an arithmetic sequence generated by recursion. So last thing for us to consider is a question that's going to vex us for a month. Does it converge? What do we mean when we say that a sequence converges? We say that a sequence A sub n converges if and only if the limit as n approaches infinity of the terms of the sequence is L for some finite L. In other words, if you take the limit at infinity and the terms settle down somewhere, some settling down at some finite number, then the sequence converges, and otherwise the sequence diverges. So let's go back 2 slides. Which of these converge? Do these terms settle down somewhere? 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 Think about it for a moment. Well, these terms all get closer and closer to 1, so we would say that the sequence A sub n converges to 1. These do not settle down anywhere. They bounce back and forth between larger and larger positive and negative numbers. These don't settle down anywhere. They just keep growing. And these just keep growing. So the only one of these 4 sequences with a limit is A sub n. So for you to think about, do they converge? The sequence U sub n, which happens to be the sequence 20 minus 4 over n squared. The sequence V sub n, which happens to be the sequence 18 times 2/3 to the n minus 1. And the sequence W sub n, where this is the sequence natural log of n squared over n. I want to know if those sequences converge. Think about that for a moment. Shockingly, breaking the fundamental law of classroom examples, all 3 of these converge. It's easy to look at the limit of this as n gets large. The n squared goes to 0, so 20 minus 0 is 20. It's easy to look at these and see that as 2/3 gets raised to bigger and bigger powers, that eats up the 18 for sure. Here we can find the limit. We find it by L'Hopital's rule. And we use L'Hopital's rule a couple of times to establish that this limit is in fact 0. So hopefully this is helpful to you. And that's all we talk about with respect to sequences.